Today we will study on chapter 8 part 2. Okay, so mass and energy analysis of control volume open system part 2. Okay, sebelum ni kita dah belajar part 1. Okay, and you also already did a lab. Okay, lab 3 adalah berkaitan dengan open system. Okay, open system I have told you before. So open system ada 3 benda yang akan masuk dan keluar dari sistem. Okay, the first thing is your mass. Okay, so mass adalah apa-apa yang ada berat lah. So any fluid. So it can be water, it can be oil, or it can be anything. Okay, that enters and leaves the system. Okay, then you have heat transfer. Okay, heat is entering and also leaving the system, and also work done by the system or on the system. Okay, so it's both ways. Okay, so open system ni ada 3. So closed system cuma ada 2. Mass tak ada. Sebab mass is control inside. Okay, so before this, in part 1 kita tengok turbine and also diffuser. Okay, so boleh tengok at the end of part 1. So we are looking at the examples of open system. So the next example is the compressor and also the fan. Okay, compressor dengan fan. So boleh tengok ada mass is entering. So this is your control volume. So control volume maksudnya volume takkan bertambah. Okay, similar like your experiment. Okay, so yang silinder kat tengah-tengah tu volume dia tak bertambah. So it's fixed. So sebab itu open system we call as a control volume. Okay, closed system we call as a control mass. So mass dalam tu is fixed. Volume akan berubah. Okay, so one of the examples for open system is compressor and also fan. Okay, so compressor and fan. So compressor and fans are principally the same devices. However, compressor operate over large pressure ratio. Okay, so kita tahu fan, okay, kipas. So kipas selalunya is not too powerful. Okay, unless you use a very powerful fan. But compressor normally it will compress and push with force. Okay, so dia ada tekanan dia lagi tinggi. So that's why the compressor are larger pressure ratio than fan. Okay, so practically prinsip dia sama. Okay, so if neglect, so this is, yang ni equation apa? Equation apa ni? Okay, so I think lab 3 ada buat. So what is this equation? So conservation of energy. Okay, conservation of energy. So equation ni adalah fixed. Equation ni fixed, tapi based on your application and based on the things that you are dealing with, you kena jadikan certain thing kosong. So after some time you tengok it's okay. Dalam case ni apa yang kita neglect. Okay, so if we neglect the changes in kinetic, so kinetic, so meaning the second part yang ada V square ni akan jadi kosong. Okay, and potential energy become 0. Okay, GZ become 0. Kemudian adiabatic, so meaning Q net and also work out akan jadi kosong. So at the end, so, apa-apa yang you jadikan kosong, you will get this. So this is the resultant formula. Okay, selepas you jadikan kebanyakannya jadi kosong, so minus W net equals to M H2 minus H1. So you ringkaskan at the end. Okay, ini adalah formula untuk compressor and fan. Okay, so W in equals to M H2 minus H1. Okay, H2 minus H1 ni apa? Okay, what is H2 minus H1? H ni apa? Ingat lagi? Air. So kalau you cakap air, So memang salah lah. Okay, so H in thermodynamic is enthalpy. Okay, yang you dapat dari thermodynamic table. Okay, value of enthalpy H. Okay, kalau dalam thermodynamic ketinggian bukannya H. Kita selalu cakap Z. Sebab dia berkaitan dengan potential energy. Okay, macam dekat sini ada Z. Yang ni adalah ketinggian. Okay, bukan H. So don't get confused. Okay, so for compressor we neglect the kinetic energy, potential energy, heat and also work done out. Sebab itu you dapat formula dia N formula like this. Okay, so we'll see one example. So nitrogen gas is compressed in a steady flow. Okay, dalam exam soalan akan macam ni lah. So it will be in this kind of form. So you'll have a situation with all the parameters. Okay, then you need to do all these stages. So kalau you tak buat stages ni, you pun akan confused. So you need to put one by one. So baru you solve. Okay, so in this question, so nitrogen gas is compressed in a steady flow. Okay, so ini adalah, so kita tahu based on the question we know, so what fluid we are dealing with. So macam ni nitrogen, yang ni under kategori apa? So nitrogen. Ya? Yeah? Fluid. Betul, fluid. Tapi fluid apa? So kalau you tak tahu yang itu adalah group apa, so you tak tahu table mana, you kena refer dalam thermodynamic table. Okay, so nitrogen gas is actually ideal gas. So ideal gas, so if you see the table, okay, thermodynamic property table. Okay, so ini adalah thermodynamic table. So dekat sini untuk nitrogen akan refer ke table mana kalau ikutkan jadual ni? A berapa? A2. Okay, ideal gas. Ideal gas, specific heat and various common gases. So kalau you tengok table A1, table A2. Tengok. So dekat sini tadi gas apa? Nitrogen. So tengok dekat nitrogen. So tengok ada formula dia, ada gas constant. So if the formula requires the value of R for nitrogen, so you ambil 0.2968. Okay, Cp and also Cv. So ini adalah specific heat. So 1.039. So yang ni Cv adalah 0.743. So if the formula is using Cp and Cv, so take from here. Okay, and the value of K 1.4. Okay, so ini adalah thermodynamic table. So actually there are a few tables that we will use, okay, throughout the subject. Okay, so go back to okay. So nitrogen is under ideal gas. So steady flow, adiabatic process. So the process is adiabatic. Okay, selepas dapat soalan ni, first you draw the schematic ataupun the sketch. Okay, then you can know. So you know is compressed. So compressor simbol dia macam ni. So yang sebelah sini adalah besar, so sebelah sini kecil. So it shows that it is compressed. So the mass is entering, so nitrogen is entering, so M in, then M out. So compressor, so work is done. Okay, electric masuk, then kerja dibuat. Okay, it's compressed. Okay, so you draw this. Okay, so diabatic process from 0.1 MPa 25 degrees. So pressure is given and also the temperature is given. So during the compression process, so dia dah bagi tahu dah compression process, the temperature becomes 1 to 5. So dari 25 degree Celsius jadi 1 to 5 degree Celsius. Okay, if the mass flow rate adalah 0.2 kg per second, determine the work done on the nitrogen. Okay, so this is the question. Okay, first, what is the control volume? So it's a compressor. So selepas dah finalize what is the control volume, so lukis. Okay, so property relation is nitrogen. So we consider as ideal gas, and you need to use the ideal gas equation. Apa itu ideal gas equation? Okay, so dalam exam, okay, for your final exam, certain formulas will be given. Tapi ideal gas equation is not given. So because ideal gas equation you something yang you belajar dari form 4, form 5. So we assume you already know. So soalan equation yang susah. Okay, so macam equation ni, so conservation of energy, yang ni diberi. So based on this, so if you know the question is related to conservation of energy, tapi you tak tahu macam mana nak kira, so at least tulis balik formula ni. At least saya bagi dah satu markah. Tapi jangan tulis semua formula dari appendix. Tak berkaitan saya potong markah. Okay, so at least saya dapatlah some marks. Okay, so this is a property relation and ideal gas relation is used. So ideal gas equation adalah PV equals to MRT. Okay, so itu adalah ideal gas equation. So the process is adiabatic, so meaning no heat transfer and steady flow. Okay, then you masuk ke solution. Solution first, what you do? You do conservation principle. Okay, conservation principle sebab yang ni one mass in and mass out. So you buat dulu conservation of mass. So mass, total mass in equals to total mass out. So M1 equals to M2. So sebab M1 equals to M2, so you just take it as a M sebab mass tak berubah. Okay, then you enter to conservation of energy. Okay, gunakan formula ni. So conservation of energy formula. Okay, salin balik formula ni, baru buat. So kalau you tengok tadi, so according to the sketch control volume, so mass and work cross the control surface. So you neglect the kinetic and potential energy, and noting that process is adiabatic and we have one entrance and one exit. So formula ni tengok. So based on apa yang you jadikan kosong, so semua dijadikan kosong. So Q jadikan kosong, yang ni adalah velocity sebab tak ada kinetic energy, tak ada potential energy, so kosong, yang ni pun kosong. So at the end, apa yang tinggal? So you ada formula ni je. So these are the formula that you will use for your calculation. So based on apa yang you jadikan kosong lah. So maksudnya formula of energy conservation tu sama, tapi based on the system you jadikan the related parameter jadi kosong. Okay, at the final, so you dapat satu formula, you gantikan. Okay, so in this case, so you want to find per unit mass. So W besar ni dijadikan W kecil. So W besar bagi dengan mass. Okay, so kalau yang formula ni bagi dengan mass, so you dapat H2 minus H1. Okay, so this is from table A2 tadi. So table A2, so the formula is, okay, this is from your previous slide, previous chapters. So W in equals to Cp. So this is for ideal gas. Ideal gas you boleh gunakan formula ni Cp. Cp dapat dari mana? Table tadi. Okay, so Cp for nitrogen. So tadi ada 4 kolom. Okay, one of the column adalah Cp. So dapatkan value for nitrogen. Cp is 1.039. Okay, so T2 minus T1. So T2 adalah diberi dalam soalan. So T2 adalah 1 to 5, T1 adalah 25. So suppose for this formula you kena convert ke Kelvin. Tapi dekat sini you just kali dengan Kelvin lah. Okay, sebab yang ni you just finding the differential. So even you convert to Kelvin pun, you still akan dapat 100. So 125 tambah 273 minus 25 tambah 273, you still akan dapat 100. Okay, so you solve, you dapat 103.9, then you convert back to Win. Okay, so dekat sini dalam soalan diberi 0.2 mass flow rate. So mass flow rate adalah m dot. Okay, so you kali balik, so you dapat the work done in adalah 20.78. Okay, so this is how you solve the question in energy analysis. So you dapat dulu dari soalan apa information yang you boleh dapat. So you receive the information, so you determine what control volume is that. Then you find the fluid involved. So check whether it's related to water. So kalau water, you pakai table A5 ataupun A6. Kalau it's related to ideal gas, you gunakan table A2. Okay. Then you find the process is adiabatic. So apply conservation principle. So ada dua conservation of mass and conservation of energy. Then you dapat formula air, then baru you start calculation. Okay. Okay, so for your final, tak ada soalan berkaitan dengan energy analysis. Okay, so you tak perlulah buat benda-benda ni. Okay, tapi yang ni setakat info lah. Because for your degree, walaupun you dapat credit transfer, so apa yang you belajar dalam ni, you akan gunakan balik. Okay, so in other subject in degree, they assume you already learn in Thermo-Fluids. So waktu tu simpan notes. Okay, simpan video. So listen back all the videos. Okay. Okay, throttling devices. Okay, so tadi kita tengok compressor. Okay, another device that related to open system adalah throttling. Apa tu throttling? Siapa tahu apa itu throttling? Throttling. So boleh tengok dekat gambar tu. Apa tu? Apa yang you faham? Okay, throttling device. So throttling maksudnya control. Okay. So katakan you ada satu pipe. So you ada apa? Apa yang dipanggil bukan pilih kan? Valve. So you have a valve. So valve yang support. So kalau you tutup valve, apa akan jadi dekat flow? Stop. Kalau you buka sikit, speed akan jadi kurang. So that is a throttling device. Okay. So apa yang you belajar dalam thermodynamic ataupun thermofluid, you will apply next semester. Okay, for pneumatic and hydraulic. Okay, so pneumatic and hydraulic is the continuation of the subject. Yang subject tu pun saya ajar. Okay, subject tu pun saya akan ajar. But then no calculation, semua design. Okay, design the circuit, gunakan software. Circuit of bukan circuit elektrik kan. So yang itu adalah circuit pneumatic and also hydraulic. So you will relate back. So maybe sekarang you tak faham, tapi in pneumatic and hydraulic you will see okay how the speed is reduced. Okay, so throttling device is something that some valve is that used in thermo system to control the speed. Okay, either you nak control the flow rate. So yang tu boleh control the temperature. So kalau you control the flow rate, automatically pressure dengan temperature akan affected, akan kurang ataupun bertambah. Okay. So open system, you have this throttling device. So it can be an adjustable valve, it can be a porous plug. So porous plug, so meaning there's something inside to control. Okay, or it can be a capillary tube. Okay. So ada flow yang besar, tiba-tiba ada satu capillary tube. Okay, sama macam art kita lah. Okay, jantung kita pun ada kan. So ada aorta. So tiba-tiba ada few salur darah yang kecil. So masukkan salur darah yang kecil, pressure akan bertambah ke kurang? Dia akan bertambah. Sebab dia dari pipe yang besar dia masuk ke pipe yang kecil. So samalah. So similar thing is applied. Okay, so even our human body is using thermo-fluids. Because kita ada heat and also ada flow. So kalau dekat art ada throttling device, pakai jantung. Okay, similar. So that's something to do with this. Okay, so for throttling device, okay, gunakan balik the conservation of mass and also conservation of energy. Okay, after you boleh tengok information apa yang dijadikan kosong untuk throttling. So after you gantikan dekat sini, so you akan dapat the final formula for throttling device is MIHI equals to MEHE. So mass is conserved. So at the end untuk throttling device, so HI equals to HE. So I adalah in, E adalah exit. Okay. So kalau nak soalan tu berkaitan dengan throttling device, so straight away use this formula. HI equals to HE. Okay, so the process untuk ideal gas, what will happen? So yang ni HI equals to HE digantikan dengan TE equals to TI. T adalah apa tu T? T, temperature. So T adalah temperature. Okay. So when throttling an ideal gas, so the temperature does not change. So that's why it's important in refrigeration. Apa tu refrigeration? Peti ais. Okay, peti ais, aircon semua gunakan prinsip yang sama. Okay, prinsip yang sama. Okay, so you can read all this information here. Okay. Ini adalah example. Okay, for throttling device. Okay, try. Okay. One way to determine the quality of saturated steam is to throttle the steam to a low enough pressure that it exists as a superheated vapor. Okay. Saturated steam at 0.4 million pascal is throttled to 0.1 million pascal. Okay, so tengok dari information ni. So this is a steam. Okay, steam meaning is a water. Okay, so you need to refer to the steam table. Okay, nanti kita tengok. Okay, so you're saying that it's a throttle. So it's a throttling device, and the pressure is reduced dari 0.4, 0.4 to 0.1 million pascal. Okay, so 100 degrees Celsius. So determine the quality of the steam. So quality adalah value X. Value X. Okay, so you draw first. So this is a throttling device. So in between you have a valve. Okay, so it's a control volume. Okay, from 1 to 2. Okay, so control volume is a throttle. Okay, so property relation is steam tables. Steam table adalah table A5 and A6. Okay, so A5 and A6. So process is a steady state, steady flow, no work, no heat transfer. Dekat sini pun you dah tahu dah. Okay, for throttling, so no work done, so no heat transfer, so no kinetic energy and no potential energy. Okay, so one entrance and one exit meaning, so M1 equals to M2. Okay, so mass 1 equals to mass 2. Okay, so you apply the conservation principle. So conservation of mass. Okay, so M1 equals to M2. So you consider it as a M. Okay, sebab dia sama. Okay, then you apply conservation of energy. So pakai formula sama. Formula the same. So ganti balik apa-apa yang you neglect. So neglect tu jadikan kosong. So Q jadikan kosong. So dekat sini H1 ada, so M1 ada. Yang kinetic jadikan kosong, potential jadikan kosong. Dekat sini pun sama. So selepas you jadikan kosong, so you will get this formula. M1 H1 equals to M2 H2. Okay, so M1 equals to M2, so cancel. So at the end you are the H1 equals to H2. Okay, then you apply this table. Okay, so this is the information given in the question. So T2 equals to 100 degrees Celsius, P2 equals to 0.1 million Pascal. So you need to find H2. Okay, so macam mana nak cari? Okay, 0.1 million Pascal and 100 degrees Celsius. So go to, sorry. So go to thermodynamic table. Okay, saturated water, so table A5. So saturated water ada dua. So if the information of temperature is given, gunakan A4. Kalau temperature atau pressure is given, so gunakan A5. Okay, so go to table A5 sebab pressure is given. Pressure is 0.1 million Pascal. So pergi ke table A5. So A4, A5. So you can see here pressure is given. Tadi berapa pressure? So 100 degrees Celsius and 0.1 million Pascal. So 0.1 million Pascal berapa? So sebab unit dekat sini adalah kilopascal, kPa. Yang tadi itu million Pascal. So 0.1 million Pascal berapa kPa? 0.1 million berapa? 0.1 million. Berapa ribu? 100 ribu kan? So 100 ribu. So refer ke 100. Okay, so refer ke 100. Tadi nak cari value apa? H, value H kan? Cari dekat sini, H. Value of H. Okay. So saturated vapor 2675. Okay, so ini yang you akan gunakan dalam formula. Okay, so you already got this. So H1 equals to H2, so 2675.8. Ini dapat dari table A6. Then you can apply this formula. HF plus, sebab kita nak find, kita nak cari the quality. Quality is the value of X. Okay, H1 equals to HF plus X1 HFG. So you jadikan dia macam ni. So you rearrange the formula. Okay, so value of HF and HFG is given in the table. So HF and HFG. So you ambil lah dekat sini value ni, 417.151 and 2257.5. Okay, so gantikan balik dekat sini. Okay, so you will get, so the value of X1 equals to 0.971. Okay, so this is how you can get the values. Okay, so another thing, so we have seen on the compressor, so we have seen on the throttling device. So another thing is mixing chamber. Okay, mixing chamber tu apa? What is mixing chamber? Apa mixing chamber akan buat? So dia akan buat mixing lah, kan? Okay, so you can see here. So you have two input, you mix, jadikan satu. So let's say this is water, this is oil. So you mix, so you akan dapat water and oil mixture. So macam tu lah. So the function of mixing chamber. So like this. So ni something that you can see in the house. Okay, hot water and also cold water, you mix, dapat air suam. Sama lah. Okay, so T elbow is an ordinary shower serve and mixing chamber. Okay, so for mixing chamber, so this is the formula. Yang ni dia dah bagi dah terus. Okay, so this something that you get from your energy conservation table, conservation equation. Okay, M1 H1 plus M2 H2. So input equals to output. So input ada dua. So M1 and M2 H1 and H2. Output is only one. M2 H3. M3 H3. Okay, so the heat transfer is 0, work done is 0. So kinetic and potential energy equals to 0. Okay, so this is the example. Okay, steam at 0.2 million Pascal. Okay, 300 degrees Celsius enters a mixing chamber and is mixed with cold water at 20 degrees Celsius, 0.2 million Pascals to produce. Aduh, jam lah macam ni. Okay, sorry for the slide. Okay, so example. Okay, so it's a mixing chamber. So steam 1 and cold water 2. So it's mixed. So apa yang panas dan cold campur, dia akan dapat saturated water. It's a mixing chamber, control surface. So you use a steam table. The steam table is A5 and A6. Okay, then the process is steady flow air diabatic mixing with no work. So ini adalah formula dia, M1 plus M2 equals to M3. So you rearrange M2 equals to M3 minus M1. Okay, so conservation of energy. So you apply all the things that you become zero, you neglect. So at the end you will get the formula equals to M1 H1 plus M2 H2 equals to M3 H3. So this is the formula that you will get. So since you want to find M1, so you rearrange this formula. So you will get in this form M3 H3 minus H2 over H1 minus H2. Okay, so use table A6. Table A6 to find the enthalpies, H, value of H. So you will carilah based on the information dapat. So T1 equals to 300 and P1 equals to 0.2. So you gunakan table A6, you akan dapat H1 equals to 3072.1 kilojoule per kg. Okay, so yang ni another thing that you can get. So T2 equals to 20 degrees Celsius, P2 equals to 0.2. So table A4, so dapat the value of H2 equals to 83.91. Okay, and the last one, so you don't know the pressure, but you know certain values. So you know it's a 0.2. So you boleh dapat dari table A5, H3 equals to 504.7. Okay, you ambil value of HF. Okay, so semua value dah dapat, H1, H2 and H3. Then you replace in this formula yang you dapat dekat sini. Okay, this is the formula that you already got. Okay, so you replace, then you get M1 equals to 2.82, so kilogram per second. So that's the mass flow rate. Okay, so you replace back in this, because one value is given 20 kilogram per second. So you already found 1 mole. So you just find M3 minus M1. So 20 minus 12.82. So you get 17.18. Okay, so this is the value that you already got. Sebab dekat sini suruh cari. So what are the required steam and cold water flow rates? Okay, so you already found M1 and also M2. Okay, so earlier we have seen on the mixing chambers. So this is heat exchanger. So heat exchanger are something unique because no interaction. So you have two part. Okay, one here. So fluid B. So you can see there's one pathway with fluid A and another pathway with fluid B. Okay, so fluid A and fluid B will have temperature different. Okay, selalunya yang part ni dia panas. Okay, fluid A will be panas, fluid B akan jadi sejuk. So what will happen? So the heat energy will be transferred to the cold water. So this fluid will be cooled down. Okay, cool down. So ataupun dekat sini, so boleh tengok fluid B is 70 degrees Celsius and fluid A is 20 degrees Celsius. So dari fluid yang panas, so heat will be transferred to this fluid. So from here 20 degrees Celsius, waktu dia keluar tu dia dah jadi 50 dah, because the heat is transferred. Okay, so you can see here also. So you have M1 and M2. So it's not like a mixing. So sebab dia fluid A and fluid B is not having any mixing. Okay, so yang ni dia keluar dekat sini, yang ni dia ada part dia sendiri. But you have an heat transfer, heat exchangers. Okay, so here M1, M2. So you see how many input are there. So input dekat sini apa? M berapa? Entering the system. Yeah. Sebab input equals to output kan. So what are the alphabet for input dekat sini? Gambar ni. Okay, one adalah M1. Okay, number 1. Apa lagi yang masuk? M3 kan? So M3. Yang keluar M2 and M4. Sebab tu dekat sini yang in you keep it at one side, exit keep it at one side. So M1 H1 plus M3 H3 sama dengan M2 H2 plus M4 H4. So this is the formula for. Okay, so there's a connection problem I think. Okay, so this is a heat exchanger. So you can see the example. Okay, for all these all these properties of open system. So it can be turbine, it can be diffuser, it can be compressor, it can be a mixing chamber, throttling device, or heat exchanger. Okay, so ada banyak. So refer back to the example. So try to understand all the example. So try to understand. Okay, so that you will understand how to do. Okay, air is heated in a heat exchanger by hot water. The water enters the heat exchanger at 45 degrees Celsius and experience 20 degrees drop. So keyword 20 degrees drop maksudnya dia kurang daripada sini. So 45 become berapa? Kalau 20 degree drop 25. So don't take 20 degrees. So students selalu buat mistake lah because didn't get. Okay, as the air passes through the heat exchanger, its temperature is increased by 25 degrees Celsius. Sebab ada 20 degrees drop. Okay. Okay, so water enters 45, so 20 degrees drop. Says the air passes. Dia ada dua. So dekat sini ada water. So dekat sini ada water, dekat sini ada air. So it's not connected. So dia ada dua entrance and dua exit yang asingan. Okay, so from the water, so 45 degrees, 20 degrees transferred to the air. Okay, so temperature of the air increased by 25 degrees Celsius. So determine the ratio of mass flow rate of air to mass flow rate of water. So m dot air bagi dengan m dot w water. Okay, so you kena cari yang tu. Okay, so this is the schematic. So ada one entrance, the two entrance, one for water and one for air, and one exit for water and one exit for air. Okay, so the control volume is the heat exchanger. So property relation, okay, so air is under ideal gas. Okay, boleh tengok dekat ideal gas table. So air is one of it. Okay, and water referred to steam table. Okay, A5 and also A6. Okay, the process is assume a diabatic or steady flow. Okay, so apply dulu conservation principle. So ada dua conservation of mass and also conservation of energy. Okay, so untuk open system you kena buat conservation of mass dulu. Okay, so mass in minus mass out equals to changes in the system. So two entrance, two exit. So sebab itu ada dekat sini. So MR1 plus MW1, so water sama dengan so MR2 plus MW2. So conservation of mass. Okay. For two fluid stream that exchanges energy but do not mix, it's better to conserve the mass of fluid stream separately. So you jadikan dia asing lah. So air asing and water asing. So you dapat macam ni lah. Okay, then you enter to conservation of energy. So you neglect the kinetic and potential energy. So we have a steady flow. So after you apply to conservation of energy principle, you akan dapat formula dia macam ni. Okay, so formula dia macam ni. So you jadikan dia simplify. So you want to find the ratio of mass flow rate of air over water. Okay, so you rearrange this formula, you akan dapat formula dia macam ni. Okay, so you apply a table A2. Okay, so ideal gas. So using a incompressible fluid approach for the water, table A3. So you dapat CP 4.18. Okay, so you gantikan balik. So replace back inside. Okay, CP. So table A2 and table A3. So you gunakan. Okay, so you gantikan balik. So this is the temperature drop, minus 20, and here minus 25. Okay, of the air. Okay, so you solve this, you dapat 3.33. Okay, this is the ratio. Okay. Okay, one more. Pipe and duct flow. Okay, duct tu apa? Bukan ET bukan duct. Okay, duct meaning is a pipe or bigger pipe. Okay, so the pipe and duct flow. So normally we can see above this pun ada. Okay, aircon punya ni kan. Tapi it's above the ceiling lah. So you can see it's control. Sebab itu kita ada centralized aircon control. Okay, tutup switch dekat satu tempat, so the whole faculty will not have. Ataupun normally 5 o'clock dia akan automatically tutup. So because it's connected through the duct pipe. Okay, pipe selalunya yang kecil lah, duct selalunya yang besar.